In this class, we are going to discuss about the conic section, which includes parabola, ellipse, and hyperbola. Okay? Now, what is the definition of a conic section? It is basically the locus of a moving point moving in such a way that it always maintain a fixed ratio between the distances from a fixed point and from a fixed line. That is what I want to say is, conic section is basically the locus of a moving point. It is moving in such a way that the distance from a fixed point, let us say, which is S, and this is the variable point, let us say A over here. It is moving in such a way that this distance and the distance from a fixed line, this ratio of the distances, that is AC by AB, is always constant and termed to be as eccentricity. Okay? For parabola, this eccentricity, that is this ratio of this distance, will be equals to 1. For ellipse, this eccentricity is less than 1, and for hyperbola, it will be greater than 1. Is it clear? Now, this fixed point is what called your focus, and this fixed line is what called your directrix. Right? So, for parabola, on a complex plane, let us say that the point S, which is the focus, is associated with the complex number, say Z0. The variable point, which is A, which is associated with the complex number, say Z. Z is a variable point. And the fixed line, which is called your directrix, the equation of directrix is, say, alpha bar Z plus alpha Z bar plus B equals to 0. Okay? Now, the distance AC is basically mod of Z minus Z0, and the perpendicular distance from this variable point on this fixed line, which is your ABC, is nothing but the perpendicular distance we know how to calculate. It is alpha bar Z plus alpha Z bar plus B divided by 2 mod of alpha. Whether you write bar or not, it doesn't matter, because mod of alpha bar and alpha, they are same. Mod of alpha bar and mod of alpha, they are same. And the distance is always given with a mod sign. Is it clear? So, in case of parabola, your AC is equals to AB. That implies mod of Z minus Z0 equals to mod of alpha bar Z plus alpha Z bar plus B divided by 2 mod of alpha. Is it clear? And that is the equation of a parabola on a complex plane. Is it okay? Absolutely. Okay. Now let us come for ellipse. We know in the Cartesian plane, the ellipse looks like this. These are the foci. Let me denote by S and S dash. The coordinate of the foci is AE, 0, and this is minus AE, 0. These are the vertices, which is A, 0, minus A, 0. This we all know from the knowledge of coordinate geometry. Now, there is one property of ellipse which says that if there is a variable point, say A, then the sum of these two distances, that is AC plus S dash A, this will be always equals to twice A. Yes or no? For ellipse, eccentricity is less than 1. Is it clear? So now, in complex plane, let us denote S by say the point z1 and s dash b z2. The variable point A is z. Okay. So what this property says about ellipse is the distance SA is mod of z minus z1, and the distance S dash A is nothing but z minus z2. Okay. The sum of these two distances equals to twice A. Right? Now can you tell me what is the distance between these two focus? The distance between the foci is basically 2AE. Right? Now in case of ellipse we know E is less than 1. Therefore 2AE will be less than twice A. Yes, since E is less than 1, so 2AE will be less than 2A. 2AE is basically the distance between the foci, which is mod of z1 minus z2. Correct? So, from this equation we will say that mod of z minus z1 plus mod of z minus z2, this is equals to 2A. This represents an ellipse when 2A is greater than mod of z1 minus z2. Tell me yes or no. That's exactly what we have proved here. 2A is what? It is basically mod of z1 minus z2. Correct? So 2A is greater than mod of z1 minus z2. If this condition holds true, then we will say that this equation on a complex plane represents an ellipse. Fine? Absolutely clear? Okay. Now let us move for hyperbola. Hyperbola. How it looks like? These are the foci. S dash minus AE comma 0. S AE comma 0. These are the vertices. A comma 0 minus A comma 0. Okay. Let us take a variable point A anywhere on the hyperbola. Now, the difference between the distances S dash A and SA be constant and equals to twice A. Then we call that A is the point lying on the hyperbola. Right? Here eccentricity is greater than 1. Foci are associated with the complex numbers, let us say Z1 and Z2. And the variable point be Z. So now you can say that S dash A is this distance. So this distance, which is your mod of Z minus Z2, and SA, which is this distance, is mod of Z minus Z1. This is equals to 2A. But think about it. If the point is here, then the distance SA will be more than S dash A. So this distance, to make it positive, I am giving a mod sign over here. Either you can write in this way or else you can write in this way also. Z minus Z1 tilt Z minus Z2 equals to twice A. Tilt means always subtract the smaller one from the higher one. According to the position of A, mod of Z minus Z1 may be higher than mod of Z minus Z2 or the other way round. So our prime motto is to make this difference between the distances positive. Is it clear? So that is why either you can write it by this way or you can write by this way. What is the distance between S dash? It is basically the distance between the foci. Is 2A. Now E is greater than 1. That is 2AE is greater than 2A. Okay. Now 2AE is basically mod of Z1 minus Z2 because this is the distance between the foci. So we will say that mod of Z1 minus Z2, this is greater than twice A, or else you can say 2A is less than mod of Z1 minus Z2, and that is the condition for which this equation will represent a hyperbola on a complex plane. Is it clear? So we have learned three things. First is for the parabola. Let me just revise very quickly. So we have learned the equation of a parabola on a complex plane. We have learned the equation of an ellipse on a complex plane, which is mod of z minus z1 plus mod of z minus z2 is twice a. And this will represent an ellipse when the condition is 2a is greater than mod of z1 minus z2. And for hyperbola, we have learned that the equation of the hyperbola on the complex plane is mod of, this is the whole mod of z minus z2 you can write, or else you can write z1, doesn't matter. Mod of mod z minus z2 or z1 minus mod of z minus z2 mod is equals to twice a, where 2a is less than mod of z1 minus z2. This is very important property. Until and unless this relation holds true, this will not represent a hyperbola on a complex plane. Right? So either you can write in this way, or else you can write in this way also, where I have written mod of z minus z1 tilt mod of z minus z2 is twice a. Correct? So these three things we have to remember. Okay? Now let us move for some problems. So I've written here the two conditions for ellipse and hyperbola. Now let me take an example. Say mod of z plus 4 plus mod of z minus 4 is equals to 10. What does this represent on a complex plane? So first of all, we will find out. Here we know that mod of z minus z1 plus mod of z minus z2, when there is a plus sign in between, we will always think about ellipse first, okay, whose foci will be at minus 4 comma 0 and 4 comma 0. Yes or no? Because this is what? Actually, mod of z plus 4 means what? It is basically mod of z minus minus 4 plus iota 0. Correct? Therefore, one focus will be at minus 4 comma 0, and the other one from the same argument, it will be 4 comma 0, right? So one is minus 4 comma 0, another one is 4 comma 0. Now what is the distance between this foci? It is 8. The distance between the foci is 8. Now we know that the distance between the foci is mod of z1 minus z2 if this is z1 and this is z2. Okay, so mod of z1 minus z2 is 8, and we can see here it is 2a. 2a means here it is 10. 2a is 10 over here. 2a is 10 over here. Now we can see that 2a, which is 10, is greater than 8, which is equals to mod of z1 minus z2. That is, 2a is greater than mod of z1 minus z2 implies that this equation represents an ellipse on an Argand plane. Yes or no? Okay. Now, whose foci is at minus 4 comma 0 and 4 comma 0? Okay. Now, when we came to know that this is nothing but an ellipse, so we can find out its eccentricity also. Let us check. The distance between the foci, which is equals to 8, is nothing but 2ae. So 2ae is 8. That implies 2a is 10. So e will be nothing but 8 by 10. That gives us 4 by 5. So the eccentricity of the ellipse is 4 by 5. Okay. Now you can find out everything regarding that. Okay. So if I want to find out what is b, how can you find out? We know that b square equals to a square into 1 minus a square. So b square will be what? A square is how much? A is how much? A is nothing but 5. So if a is 5, it is 25. 1 minus e is how much? E is 4 by 5. So simply plug in. So 16 by 25, that gives us 9. Okay. So b is nothing but 3 only. Is it clear? Now if you want to find out the length of the lattice rectum, that also you can find out, which is nothing but 2b squared by a. So which is simply 2 into 9 divided by 5. That is 18 by 5 units. And so on and so forth. Okay, so you can find out everything regarding the ellipse once you have identified the locus of z on the complex plane as an ellipse. Is it clear? Absolutely? Okay. Now let us take another problem. If mod W is 2 and Z is W minus 1 by W, find out the locus of the point Z. That's the question. So let us try to find out. Mod W is 2. Let me say W is nothing but 2 e to the power iota theta. In Euler's form, it is 2 e to the power iota theta. So Z will be 2 e to the power iota theta minus 1 by 2 e to the power iota theta. So that gives us 2 cos theta plus iota sin theta minus 2. This is actually e to the power minus iota theta. So that gives us cos theta minus iota sin theta. I'm sorry, this is half. Okay, because 1 by 2 is there. So now if I open the brackets, we are going to have 2 minus half cos theta plus iota 2 plus half sin theta. That gives us 3 by 2 cos theta plus iota 5 by 2 sin theta. Is it clear? Now if the variable point Z be x plus iota y, so we can write this thing as, if I compare, we are going to have x is 3 by 2 cos theta and y is 5 by 2 sin theta. Okay, this is actually the parametric form. Therefore, if I eliminate theta, which is x by 2x by 3 whole square plus 2y by 5 whole square, that gives us cos square theta plus sin square theta, which is nothing but 1. So from there we can write 4x square by 9 plus 4y square by 25, that is equals to 1. Yes or no? So this represents an ellipse. This represents an ellipse. Right? Now, you can easily see from here that it is basically x square by 3 by 2 whole square plus y square by 5 by 2 whole square equals to 1. Since B, this part, because the general equation is x square by a square plus y square by b square equals to 1. When b is greater than a, in this case that is happening actually, the ellipse will be a vertical one, right? It will be an vertical ellipse. Is it clear? Now I'm not going for finding out its eccentricity, length of latus rectum and all these things, because that you can do it by yourself, because this is all about your coordinate geometry. So I don't want to longer this video doing those things. Is it clear now? Absolutely? Okay, let us take another problem. See this question. Find the number of solutions of equations mod of z minus 4 plus 4 iota is root 10 and mod of z minus 3 plus 5 iota plus mod of z minus 5 plus 11 iota equals to 4 root 5. That is, this question demands that how many number of point of intersection we will have for this and this curve. Okay. So first of all, we have to identify which curve is this one as well as which curve is this one. Now from this first one, we can easily say that it is nothing but a circle whose center is at 4 plus 8 iota and radius is root 10. Okay, that is the coordinate of its center is 4, 8 and radius is root 10. Now what about this? Whenever there is a sum of distances which is equals to some constant, we will always think about ellipse. First we will check whether this equation represent an ellipse or not. If not, then we will think something else. But first thing that it should come in our mind, whenever there is a plus sign in between the two distances, we will always think about ellipse and we will try to satisfy whatever condition that we have. We know that mod of z minus z1 plus mod of z minus z2 equals to twice a represents an ellipse when 2a is greater than mod of z1 minus z2, where z1 and z2 are the foci of that ellipse. In this case, the foci is 3 plus 5 iota, that is the point is 3, 5, and 5 plus 11 iota, that is 5, 11. Okay. Now, the distance between the foci, which is nothing but your 2 times AE, E is the eccentricity of the ellipse, which is equals to, let me just calculate this. So this gives us under root 4 plus 36, that is under root 40. Okay. Now you observe one thing, that here 2a is basically 4 root 5, which is, if I take this 4 inside the root sign, so it will be under root 80, which is greater than root of 40. That is, 2a is greater than the distance between their foci. That is mod of z1 minus z2. Therefore, with guarantee we can say that this equation represents an ellipse. That's for sure. Is it clear? So, for this ellipse, the foci are at 3, 5 and 5, 11. So, the center of this ellipse will be, 3 plus 5 iota plus 5 plus 11 iota divided by 2, which is nothing but, because this is the midpoint of the center, is always the midpoint of the foci. So it is coming to 8 plus 16 iota divided by 2 gives us 4 plus 8 iota. That is 4, 8. Now can you observe one thing? The center of the ellipse and the center of the circle, they coincides. Okay. So the center of the ellipse and the center of the circle, they coincide. They are the same point. The ellipse will look something like this. Let us say this point is, say 3, 5, which are the foci. This is 5, 11, and this is the center, which is 4, 8. Okay. Now, this distance is basically AE. 2AE is our root 40. So A is how much? Root 40 divided by 2. That gives us root of 10. That is, the circle whose center is at the origin and radius is root 10 means the circle will definitely pass through this foci. Okay. Now the question comes, if the circle is passing through this foci, now we have 3 cases. Either this circle will not touch this ellipse, but it will pass through the foci, or it can touch this ellipse at 2 points, or else it will intersect the ellipse at 4 points. These are the 3 options we have. Are you getting my point, what I'm saying? For this ellipse, if these are the 2 foci, the center is here, the circle can be like this. Okay? Or else the circle can be like this. Yes or no? Where these are the 2 foci. Okay? And this is the center. Or else the circle can be like this also. Passing through 2 foci, but it is intersecting the ellipse. So for this one we will have no solution because there is no point of intersection. For this one we will have 2 solutions, and for this one we will have 4 solutions. Tell me yes or no. Now it all depends on this distance. Okay, this distance we have to calculate, and for the ellipse this distance is nothing but b. We know that b square is a square into 1 minus e square for ellipse. We have 2a as 4 root 5. Therefore, a is nothing but 2 root 5. So, if I put it here, what we are going to have? It's 20. 1 minus e I got. E I haven't calculated, right? So, let me just calculate e. Here, a is, what is a? A is root 10. A is 2 root 5. So, e is what? Root 10 by 2 root 5, which gives us 1 by root 2. Therefore, e is 1 by root 2. Let me put it here. So, we are having what? 20 into half, that gives us 10. So, b is coming to root 10. Hello? B is coming to root 10. That is, this distance is also root 10, which is nothing but the radius of the circle. Therefore, the circle is passing through this foci and touching the ellipse at only 2 points, at these 2 points, which is 0, B and 0, minus B. Yes or no? Yes or no? It's not 0 actually, but because the origin has been shifted, so it will be not 0. The abscissa will be different, but I'm not concerned about that. But one thing for sure, that this distance will be B. Okay, so which is nothing but root 10. Therefore, the circle is touching the ellipse at 2 points. Hence, the number of solution for these two equations in this case will be 2. And that will be your answer. Have you got it? Have you got it clearly? Okay. Now let me just move for another problem. See this problem. Mod of z minus 2 minus 3 iota plus mod of z plus 2 minus 6 iota equals to 4. Find the locus of the point P. So in this case, whenever I see that there is a plus sign in between two distances, we will first, what I told you, we will first think about ellipse. Okay, if it represents an ellipse, then what will happen? What is the format? Then your 2a has to be greater than mod of z1 minus z2. Then only this equation will represent an ellipse. Here you observe your z1 is 2 plus 3 iota and z2 is minus 2 plus 6 iota. Are you getting my point? Because mod of z minus 2 minus 3 iota can be written as mod of z minus 2 plus 3 iota. And mod of z plus 2 minus 6 iota can be written as mod of z minus 2 plus 6 iota. Am I correct? So these are the foci. If it at all represents an ellipse, then z1 and z2 are the foci. So here the foci are these two. Now, what is mod of z1 minus z2? This is okay, so this is 5. That is, the distance between the foci is 5. But what was my condition such that this equation will represent an ellipse? When 2a, which is here, is 4, should be greater than mod of z1 minus z2, which is 5 over here. But this is not true. So guaranteed, this does not represent an ellipse. Then what does it represent? See, here it is z1 and here it is z2. So z cannot be anywhere outside the line joining z1 and z2, because if z is over here, then the sum of these two distances must be greater than this. Why? Because we know that the sum of two sides of any triangle is greater than the third side. But in this case, it is not satisfying. Because the sum of the distances of the variable point z from z1 and z2, it has been given in the question that it is equals to 4. But the third side, which is mod of z1 minus z2, is coming to 5. Therefore, the sum of the two sides of this triangle is not greater than the third side. Hence, it will not form any triangle. Is it clear? So, the only option is that this z can be on this line joining z1 and z2. But if it is so, then we will say that mod of, if z is here, then we must say that z minus z1, that is this distance, plus mod of z minus z2, that is this distance, must be equals to mod of z1 minus z2. Tell me yes or no. But mod of z1 minus z2 is 5. But they have given that the sum of these two distances is 4. Therefore, z cannot lie on the line joining z1 and z2. So, z cannot be outside this line, z cannot be on this line. Therefore, we will say that this equation does not hold true for any z. Am I correct? Therefore, the locus of z will be nothing. That is phi over here. Why? Because neither of these two conditions are satisfying this equation. Z is outside this line, that is also not satisfied. Z is on this line, that is also not satisfied. Are you getting my point? Therefore, the locus of Z is not possible. That is, this equation is not at all possible in this case. Is it clear? Therefore, we will say that the locus of Z is phi straight away. Okay? Nothing, no locus we will get out of it. Okay? So that's all for this class. See you in my next video. Till then, goodbye and take care.